Now, in this lecture, we find out the value of x. In the drawing, we have a quarter circle. Inside this quarter circle, we have this square ABCD. And we also know that line segment DE equals to 12 units in its length. This is angle GDC is equal to theta. And this is also angle CDB. This is also equals to theta. And our mission is to find out the length of this line segment GD is equal to x. We have to find out the value of x. So first of all, because of the fact that ABCD is a square, we know that all the angles inside a square are right angles, so this angle equals to 90 degrees in its size. This is also a right angle. This angle equals to 90 degrees. Finally, this angle also equals to 90 degrees in its size. In the next step, we will extend line segment GD and line segment EA until they touch each other. And we define the touching point as point H. So here we have, if we focus on the upper side of the straight line HB, at point A, the sum of the angles must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. And we will extend side CD of this square, a straight line. So here, those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. But this angle is theta, therefore this angle must be also equal to theta. We know that angle AQC is a right angle, and this angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus theta. Likewise, we have here the extended side CD by a straight line, and here we have this angle is a right angle because it is one of the angles of square ABCD, and all the angles of square ABCD are right angles, and therefore the missing angle here must be equal to 90 degrees, according to the rule that the sum of the angles on the lower side of the straight line FC at point D must be equal to 180 degrees. Therefore, this missing angle must be equal to 90 degrees in its size. So 90 degrees, the big angle minus theta, is the sides of angle ADH. Okay, so this angle must be equal to the big angle that is 90 degrees minus theta. In the next step, we'll prove that the right triangle ADH is congruent to the right triangle ADB. That those two right triangles congruent to each other. So why those two right triangles congruent to each other? So first of all, so write it down, we prove that the right triangle ADH is congruent to the right triangle ADB. Okay. It's actually we prove that the right triangle ADH is congruent to the right triangle ADE. So why those two right triangles congruent to each other? First of all, those triangles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So this is angle ADH. In the right triangle ADH, and it is equal to this angle, this is actually angle ADB. Angle ADE. They are both equal to 90 degrees minus theta, therefore they are equal to each other. Repeat again. Angle ADH in the right triangle ADH equals to angle ADE in the right triangle ADE. They are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, side AD is the common side that belongs to both triangles, so you can write down that AD equals to itself. It's the common side that belongs to both triangles. So AD equals to itself, it's a common side that belongs to both triangles. And finally, those triangles, they are both right angles, therefore they are equal to each other. So this is actually angle HAD in the right triangle ADH, and it is equal to this angle, that is actually angle EAD in the right triangle ADE. Repeat again, angle HAD in the right triangle ADH equals to angle EAD in the right triangle ADE. They are both equal to 90 degrees, therefore they are equal to each other. So actually proved that this right triangle AHD congruent to this right triangle ADE. According to side angle similarity rule. Angle side angle rule. Angle side angle rule. Actually proved that those two triangles can go into each other according to angle side angle rule. So what is angle side angle rule? If you prove that two angles in the side that included between the two angles in one triangle are correspondingly equal to two angles in the side that included between the two angles in the second triangle, then you actually proved that the two triangles can go into each other according to angle side angle rule. And we actually proved that those two angles and the side that included between those two angles, that is side AD in the right triangle ADH, are correspondingly equal to those two angles and the side that included between those two angles, that is side AD in the right triangle ADE. Therefore, those two right triangles can go into each other according to angle side angle rule. Check again. The right triangle AHG is congruent. This is the sign of congruent to the right triangle ADE according to angle side angle rule. And from the fact that those two right triangles can go into each other, we derive that HD in the right triangle ADH is equals to DE in the right triangle ADE. This again, we derive from the fact that the right triangle AHD is congruent to the right triangle ADE, that HD equals to DE. According to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the two corresponding sides, that is to say HD and DE, must be also equal to each other. But DE equals to 12 units according to what is given in the question, so we can write down that DE equals to 12, and from this equation HD equals to D equals to 12, we derive that HD is also equals to 12 units in its null. So this side HD also equals to 12 units in its null. Likewise, from the fact that those two right triangles can go into each other, we derive that side edge A in the right triangle ADH is equal to side AE in the right triangle ADE. Again, from the fact that the two right triangles can go into each other, we derive that AG equals to HA equals to AE according to the sum rule that corresponding sides in congruent triangles are equal to each other. But we know that AFE is a quarter circle, and therefore AE must be the radius of the quarter circle. We define the radius of the quarter circle as capital R. So AE equals to capital R according to our definition, and from this equation, A equals to capital R, we derive that A must be also equal to capital R. And J equals to capital R. Okay. So in the next step, we will join points G and E together by straight line. and so here we join point G and A together by straight line. What is the definition of line segment HG? Line segment HG starts from the point A, that is the center of the circle that can be created by completing the quarter circle to a circle. So it starts from the center of the circle and ends at point Z, that is the point on the circle itself. So this is exactly the definition of a radius. Therefore HD, AG is the radius of this circle, that is equal to capital R according to our definition. So if we focus on triangle HGA, if we focus on triangle HGE, this triangle HGE, the distance of the vertex G from A is R, the distance of vertex E from point A is also R, and the distance of vertex H from point A is also R. So at point A, the distance of the three vertices from so the distance of the three vertices H, G and E from point A are equal, and therefore point A is the circumcenter of triangle HGE. So it is actually the circumcenter of a triangle is the center of the circle that blocks the triangle. So, and if a circle blocks triangle, if we have circle that blocks triangle HGE, it means that it must pass through its vertices H, G and E. Okay, and the center of the circle is at point A. Okay, so we know that we have a circle that blocks triangle HGE from one side, but from the other side, if you complete this quarter circle to a circle, the center of the circle that will be created by completing the quarter circle to a circle, the center must be also at point A, and obviously the circle passes from point G and E. So we have two circles that have the same center, that is to say A, and they both passes from point G and E. Therefore, the two circles are congruent to each other. They're actually identical. And therefore, if we complete this quarter circle to a circle, it must pass through point H, exactly as the circle that blocks triangle HGE. The circle that blocks triangle HGE passes through point H, and therefore the circle that is actually the same circle that will be created by completing this quarter circle to a circle must also pass from point edge. Okay, so here if we complete the quarter circle to a circle, it must pass from point edge. And we have EA equals to R, AH equals to R. So in total, EH equals to 2R, and here angle edge AE is a right angle, and therefore edge AE is a straight line, and the size of the straight line, the length of the straight line edge AE equals to 2R, and it passes through the center of the circle, and therefore it must be the diameter of the circle. So EH is the diameter of the circle, and we have peripheral angle HGE. This is peripheral angle HGE that is subtended on edge E, that is the diameter of the circle, and therefore it must be equal to 90 degrees. Any peripheral angle that rests on the diameter of the circle must be a right angle. So this angle equals to 90 degrees in its size. If we focus on quadrilateral DGAB, inside this quadrilateral DGAE, the sum of those two angles are both right angles. So 90 degrees plus 90 degrees, it is 180 degrees. So any quadrilateral that has two opposite angles that the sum of them is 180 degrees is a cyclic. So this is a cyclic quadrilateral, and we have a rule. It's actually rule 12. According to rule 12 is true in any circle. In any circle, if we have the common external point P, in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. So here we know that we can block quadrilateral ADGE inside the circle, and therefore we can implement the rule 12. According to rule 12, HD times HG equals to edge A times edge E. And again, according to rule 12, edge D times edge G equals to edge A times edge E. Edge D equals to 12, edge G equals to 12 plus X, equals to edge A, that is R, times edge B, that is R plus R, that is 2R. So if we're going to find out that 12 times 12 plus x equals to R times 2R. Here we divide this equation 1 by 2, and we get that 12 over 2 is 6, so 6 times 12 plus x equals to R times R is R squared. Here we divide this equation 1 by 6, and finally we get that 12 plus x equals to R squared over 6. Here we subtract 12 from this equation 1, and we get that according to equation 1, x equals to R squared over 6 minus 12. Okay, so according to equation 1, x is the variable that we are looking for, is equals to R squared over 6 minus 12. Okay, so we know that ABCD is a square, so we define one side of this square as y, and therefore all the other side will be equal to y. And we focus on the right triangle ADE. This right triangle ADE. So I copy triangle ADE in a new page, and we'll implement on this triangle ADE the Pythagoras theorem. Here by PT is the evaluation for Pythagoras theorem. Side AD equals to y according to our definition, because it is one side of square ABCD. AE is the radius of the circle that will be created by completing this quarter circle to a circle, so it is equals to capital R. And DE equals to 12 units according to what is given as the question. So in the this right triangle ADE, according to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So here the hypotenuse is DE, therefore the square of the hypotenuse is DE square, and it must be equal to AD square plus AE square. DE equals to 12, therefore DE square is 12 squared, that is 144, and it is equals to AD square. AD is y, therefore AD square is y square plus AE square. AE is r, therefore A square is r square. So in conclusion, we can find out that according to equation 144 equals to y square plus r square. In the next step, we join points A and C together by a straight line. And we'll implement the Pythagoras theorem on the right triangle, triangle ABC. This right triangle, triangle ABC. So copy the right triangle ABC in a new page and we'll implement on it the Pythagoras theorem. AC is the radius of the big circle that is equal to capital R according to our definition. A B equals to Y, also according to our definition, and CB also equals to Y. Here by PT is the abbreviation for Pythagoras theorem. So actually, this is the right triangle ABC that I copied from the original drawing. According to the Pythagoras theorem, in this right triangle ABC, you get that AC square equals to AB square plus BC square. AC is R, therefore AC square is R square, and it is equals to AB square, that is Y square, plus BC square, that is also Y square. So R square equals to Y square plus Y square, that is 2Y square. R square equals to 2Y square. We divide this equation by 2 and finally we get that according to equation 2, Y square equals to R square over 2. This is according to equation 2. While according to equation 1, we have already found out that Y square plus R square equals to 144. So I write it down here. According to equation 1, Y square plus R square equals to 144. So here we can substitute Y square in this equation, equation 1, by R square over 2 from equation 2. We'll do it now and we get that according to equation 1, Y square is R square over 2 plus R square is equal to 144. Here we divide R square by 2 and then we multiply it by 2 in order to have a common factor with R square over 2. And we get that R square plus 2R square over 2 equals to 144. R square plus 2R square is 3R square over 2. that equals to 144. Here we will multiply this equation by 2 and then we divide it by 3 and we get that r squared, only to equation 1, r squared equals to 2 times 144, that is 288 over 3. Okay, so and 288 over 3 is 96. So if we found out that r squared equals to 96, here, according to equation 1, we found out actually that r squared equals to 96, and we have already found out actually that x equals to, according to equation 1, x equals to r squared over 6 minus 12. So I write it again. According to equation 1, x equals to r squared over 6 minus 12. So we already found out that r squared equals to 96, so we can substitute r squared in this equation by 96. And we get that x equals to r squared is 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. So if I found out that x equals to 4 units in its length. Okay, so here the length of line 7 DG is equal to x, is equals to 4 units in its length. So in the next step, I'll summarize the lecture. In this lecture, I found out the length of this 97 DG is equal to x. So in the drawing you have a quarter circle, FEA is a quarter circle. Inside this quarter circle we have square ABCD. We know that line segment DE equals to 12 units in its length, and this is angle GDC, that is theta. This is angle CDB, that is also theta. Again, our mission is to find out the length of this line 7 DG that is equal to x according to what is given as the question. Okay, so first of all, because of the fact that ABCD is a square, we know that all the angles inside the square are right angles, so those 4 angles, they're all right angles. In the next step, we actually extended line segment GD and also line segment EA until they touch each other at this point. This is their touching point. We define their touching point as point H. And then we have here If you focus on the upper side of the straight line edge E at point A, here the sum of the angles must be equal to 180 degrees. So which angles we have at the upper side of edge E at point A? We have this angle that is right angle plus the missing angle. In total they must be equal to 180 degrees. Therefore the missing angle here must be equal to 90 degrees in its size. And we extended side CD by a straight line till point F. So we know that this angle equals to 90 degrees. Therefore the missing angle must be equal to also 90 degrees. According to the rule, the sum of the angles on the lower side of the straight line FC at point D must be equal to 180 degrees. Therefore the missing angle FDA must be also equal to 90 degrees. Okay, and those two angles are defined as vertex angles, and we know that vertex angles are equal to each other. But this angle is theta, therefore this angle must be also equal to theta. So what is the size of this missing angle? The missing angle must be equal to the big angle FDA that is 90 degrees minus this angle that is theta. So the missing angle here must be equal to 90 degrees minus theta. Likewise, we have this angle CDA is a right angle because it is one of the four right angles of square ABCD. Therefore it must be a right angle. So angle CDA, this angle is a right angle. So we have here angle ADB, that is the missing angle, that must be equal to the big angle CDA, that is 90 degrees, plus minus theta. So the big angle that is 90 degrees minus theta must be equal to the missing angle. Therefore the missing angle here must be equal to 90 degrees minus theta. In the next step we actually proved that those two right angles can go into each other. Why those two right angles can go into each other? First of all, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. In addition, side DA is a common side that belongs to both triangles, therefore we can write down that side DA equals to itself as a common side that belongs to both triangles. And finally, those two angles are both right angles, therefore they are equal to each other. So actually proved that those two right angles, triangle ADH and triangle ADE, can go into each other according to angle side angle rule. So what is angle side angle rule? If we actually proved that two angles and the side that is included between the two angles in one triangle are correspondingly equal to two angles and the side that is included between the two angles in the second triangle, then we actually proved that the two triangles can go into each other according to angle side angle rule. And we actually proved that those two angles and the side that is included between those two angles, that is side AD, are correspondingly equal to those two angles and the side that is included between those two angles, that is the same side AD, in the right triangle, triangle ADE. Therefore, we actually proved that those two right angles can go into each other according to angle side angle rule. And from the fact that those two right angles can go into each other, we derive that side AGD equals to side in the right triangle AHD is equal to side DE in the right triangle ADE, according to the rule that corresponding sides in congruent triangles are equal to each other. Those two right angles can go into each other, therefore the corresponding sides, that is to say AGD and DE, must be also equal to each other. So AGD equals to DE, but DE equals to 12. According to what's given us the question, DE equals to 12. So we can write here that D equals to 12, and from this equation D equals to 12, we derive that HD also equals to 12. Okay, here HD also equals to 12. units in its length. Likewise, from the fact that those two right triangles converge to each other, we derive that side edge A in the right triangle AHD is equal to side AE in the right triangle ADE. And again, we derive that side edge A equals to side AE. But we know that AE, because of the fact that FEA is a quarter circle, AE must be the radius of the quarter circle. And we define the radius of the quarter circle as capital R, and therefore AE equals to capital R. So we can write here that AE equals to capital R according to our definition. And therefore from this equation edge A equals to capital R, we derive that edge A also equals to capital R. Here, edge A also equals to capital R. Okay, and here we join points A and G together by a straight line. What is the definition of line segment AG? Line segment AG starts from the center of the circle that can be created by completing the quarter circle to a circle and ends at point G, that is the point of the circle itself. So this is exactly the definition of a radius. Therefore, HG is the radius of the circle. That's equals to capital R. Then we join point G and D together by a straight line. In this way, we created triangle edge GE. And this triangle edge GE, this point A is the circumcenter of triangle edge GE. Why point A is the circumcenter of triangle edge GE? Because of the fact that point A, the distance of the three vertices G, H, and E from point A is equal. That is to say, GA equals to R, EA equals to R, and AJ also equals to R. Therefore, point A is the circumcenter of triangle edge GE. And because of the fact that point A is the circumcenter of triangle edge GE, the circumcenter is the center of the circle that blocks triangle edge GE. Again, point A must be also the center of the circle that blocks triangle edge GE. So, and this, any circle that blocks triangle edge GE must pass for its three vertices G, E, and H. So, we actually know that we have here a circle that blocks triangle edge GE and passes for point G, E, and A, and its center is at point A from one side. But from the other side, if we complete this quarter circle to a circle, then the center of the circle that will be created by completing the quarter circle to a circle must be at point A. And it is clear that the center, that the circle also passes for point G and E, because the quarter circle passes for point G and E. So we have here two circles that have the same center, that is A, and they are both passes for point G and E. And therefore those two circles actually are identical. Those two circles are identical. That is to say, the circle that will be created by completing this quarter circle to a circle must pass through point H. Okay, because of the fact that the circle that blocks triangle GEH is the same circle that will be created by completing this quarter circle to a circle, it means that the two circles are identical, and therefore the circle that will be created by completing this quarter circle to a circle must pass through point H. Okay, and we have here angle EAH equals to 180 degrees, and therefore EAH is a straight line. EAH is a straight line, and the length of this straight line is R plus R, that is 2R. So we have a straight line that passes through the center of the circle, that is to say from point A, and it is equals to 2R. That is to say, it must be the diameter of the circle. So we know that EAH is the diameter of the circle, and therefore the circle that will be created by completing this quarter circle to a circle must pass through its diameter. That is to say, it must pass through point H. Okay? So we know that we have here a circle, and peripheral, and E edge is the diameter of the circle, and we have this angle, this is peripheral angle EGH, that is subtended on EH, that is the diameter of the circle. And therefore, this angle must be equal to 90 degrees in its size, because any peripheral angle that is subtended on the diameter of the circle must be equal to 90 degrees. Therefore, this angle must be equal to 90 degrees. And therefore, if you focus on this quadrilateral ADGE, we have those two angles are right angles. Any quadrilateral that has two opposite angles, that the sum of them is 180 degrees, is a cyclic. That is to say, we can block this quadrilateral by a circle. Okay? And therefore we can implement here rule 12. According to rule 12, we have here, actually, we have here a quadrilateral. This is actually quadrilateral. This quadrilateral ABCD is blocked by this circle, and we have the common extra point, point P. So in this drawing, the following equation is true, that PA times PB equals to PC times PD. Again, PA times PB equals to PC times PD. We can actually implement rule 12 in our drawing. Well, because according to rule 12, we have here, we can block this quadrilateral ADGE by a circle, and therefore according to rule 12, we will get that HD times HG equals to HA times HE. Again, HD times HG equals to HA times HE. Okay? And again, according to rule 12, HD times HG equals to HE times HE. HD equals to 12. HG is 12 plus X, and it is equal to HA, that is R, times HE, that is R plus R, that is 2R. So we're going to actually find out that 12 times 12 plus X equals to R times 2R. Here we divided this equation 1 by 2, and found out that 12 over 2 is 6. So in this type of equation we have 6 times 12 plus X equals to 2R squared over 2 is R squared. We divided this equation 1 by 6, and found out actually that 12 plus X equals to R squared over 6. Here we subtracted 12 from this equation 1, and finally found out that X equals to R squared over 6 minus 12. X is the variable that we are looking for, and found out that according to equation 1, x equals to r squared over 6 minus 12. Then we implemented the Pythagoras theorem on the right triangle ADE. So I copy the right triangle ADE here in the new page. This is the right triangle ADE that I copied from the original drawing. We actually defined one side of square ABCD as y, and therefore all the four sides must be also equal to y. AD equals to y, and AE is the radius of this circle is equal to capital R, and DE equals to 12 according to what is given as the question. So this is the right triangle ADE that according to the original drawing, according to the Pythagoras theorem, we get that we get here that DE squared equals to AD squared plus AE squared. DE is 12, therefore DE squared is 12 squared, that is 144, and this equals to AD squared. AD is y, therefore AD squared is y squared plus AE squared. AE is capital R, therefore A squared is capital R squared. So conclusion, we found out that according to equation 1, 144 equals to y squared plus r squared. Okay. Then we joined points A and C together by a straight line. By joining points A and C, we created the right triangle ABC. So copy the right triangle ABC in the new page, and we implemented in the right triangle ABC the Pythagoras theorem. So here we have, this is the right triangle ABC that I copied from the original drawing. In the right triangle ABC, according to the Pythagoras theorem, AC squared equals to AB squared plus BC squared. Again, AC squared equals to AB squared plus BC squared. AC is y, therefore AC is r, therefore AC squared is r squared, and it is equals to AB squared. AB is y, therefore AB squared is y squared plus BC squared. BC is y, therefore BC squared is y squared. So conclusion, we found out that r squared equals to y squared plus y squared, that is 2y squared. We divided this equation 2 by 2, and finally found out that y squared equals to r squared over 2. This is according to equation 2, but according to equation 1, we already found out that y squared plus r squared equals to 144. So we can substitute y squared in this equation 1 by r squared over 2 from equation 2. We did it, and we got here that according to equation 1, y squared is r squared over 2 plus r squared, that is equal to 144. Here we multiplied r squared by 2, and then we divided by 2, not to common factor, r squared over 2. So r squared plus 2 times r squared is 2r squared over 2. That is equal to 144. R squared plus r squared is 3r squared over 2. That is equal to 144. Here we multiplied this equation by 2, and then we divided it by 3. And finally found out actually that according to equation 1, r squared equals to 2 times 144, that is 288, divided by 3. 288 over 3 is 96, so actually found out that r squared equals to 96, and we have already found out that x equals to r squared over 6 minus 12. Now we can substitute r squared in this equation by 96 from equation 1. We did it, and we got that x equals to r squared, that is 96 over 6 minus 12. 96 over 6 is 16, and 16 minus 12 is 4. So in conclusion, I actually found out that x equals to 4 units. Here, this line 7 dg is equal to x according to our definition. According to what is given as the equation, dg is equal to x is equal to 4 units in its length. Okay, thank you very much.